So, good day everyone. My name is Gabriel Angelo Batalier from ECE1, and in this video we are going to discuss about LED blinker and more specifically LED scoreboard. So, without further ado, let's go. So, before we tackle about LED, more before we tackle about more in-depth discussion about LED blinker, let us first define what LED blinker means. So an LED flasher circuit is a circuit which flashes the LED, meaning turns it on and off. On, off, on, off, on, off. So the 555 timer is very versatile IC because when connected correctly, it can create pulses of current at specific time intervals and decided by resistor capacitor network. So later we will more tackle about the resistor capacitor network uh, more technically. So let's go next slide. So this is the for requirements for chemistry special topics NASC 2011. So in this slide you can see the prototype images and you can see the capacitor and resistor and LED as well as a transistor. So based on these images, you can have an idea on the capacitor resistor network, on how it works or maybe not. So let's discuss it. So later we will have an prototype circuit analysis. So you can see here the schematic diagram of a simple LED flasher, which is the simplest LED blinker innovation that I had researched. And as you can see in these images, the schematic diagram. So next slide. So in this prototype, the following components are transistor, LED, and capacitor. So let's define each one of them. So a transistor is a device that regulates current or voltage flow and acts as a switch or gate for electronic signals. Transistors consist of three layers of semiconductor, but each capable of carrying a current. So as you can see, there are three terminals of a transistor, and it is responsible for the turning on and off, or more technically, it is responsible for um, electrical signals in a circuit. And next is an LED. A light emitting diode or LED is a semiconductor device that emits visible light when an electric current passes through it. So the light is not particularly bright, but in most LED, it is monochromatic. So monochromatic means it is occurring at a single wavelength. Next component is the capacitor. It is a device that stores electrical energy in an electric field, while some capacitance exists between any two electrical conductors. So as you hear earlier from the previous slide, capacitor is involved in resistor capacitor network. So it is the capacitor is responsible for absorbing the charge temporarily from the circuit before it reaches to the LED. And if the charge from the capacitor is released or discharged and um, it passes through the LED, then the LED will emit a visible light. So next slide is the prototype demonstration. So before we tackle all the how this works, the materials that we need is two pieces of 1K resistor, two pieces of 22 kilo ohms resistor, two pieces of 100 microfarad capacitor, 2 pieces of BC548 transistor, 2 pieces of LED. The color is optional, of course. And next is battery clip, optional, and 1 piece of 9 volts battery for our source. So let's discuss how this works. So let's take a look at the bottom part of the schematic diagram. As you can see from the animation, it is blinking. The LED is not emitting light at the same time. Um, so yun, let's take a look at the bottom side, and you can see that the electrons are, or the currents passes through the emitter of a transistor transistor 1 and 2, which is labeled as Q1 and Q2, and then it passes through the capacitor and the LED. As you can see, the capacitor absorbs the charge and then release it in the LED. Then the LED will emit the light. So and for the resistor are is res, the resistors are responsible for reducing the current that is absorbing the circuit, so that our LED will not get busted because of high source, because a regular LED has a voltage rating of 1.5 to 3 volts if I were not mistaken. So our source is 9 volts, which is very high, so that we need four resistors rather, so in order for our circuit to work. So um, next is, as you can see, it is the LED scoreboard images. So these images represents the what do you call it? Um, yeah, it represents the innovation circuit. So as you can see, there are a lot of components that is present here. The LED, the number of LED are overwhelming, I guess, for the previous circuit that I showed to you. And there are a lot of transistor, and um, there is capacitor and resistors, and as well is, and at the first glance we can tell that the circuit are more complex than the previous one. So let's discuss. So as you can see, this is the innovation circuit, and as you can see, the transistor are not present anymore, and it is being replaced by an IC, or an integrated circuit. It is now the responsible, or the most important components in this circuit. So let's discuss what does it mean. So as you can see, um, the only thing that was changed from the previous one and to this one is the integrated circuit, and the transistor is not present anymore. So let us define first what is an IC means, or integrated circuit. For those who doesn't know, um, an integrated circuit is composed of thousands or millions of transistors, which is responsible for electrical signals also, and acting as a switch or gate. So technically, an integrated circuit is a set of electronic circuits on one small flat piece of semiconductor, usually silicon. It is used to be a single component that can perform high-level tasks such as amplification, signal processing, and even digital calculation, as in the case of microprocessor. So based on this definition, we can tell that IC is we can tell that the IC is it is used more in the more complex circuit, or more um, more powerful circuit, I guess. So, and the LED and capacitor is still present, but sometimes the LED are being replaced with more power LED, because as you can see, the um, from the diagram earlier that there are a lot of LED, so that the IC can handle all of it and control every one of them. So next slide. So short trivia. Did you know that the light emitting diode or LED was invented by Nick Holonyak? He is an American engineer and educator. On October 9, 1962, Nick Holonyak was noted particularly for his invention of a LED that emitted visible red light instead of infrared light. So, another invention of Nick Holonyak aside from the LED is the laser diode. So, for those who doesn't know, an LED diode, laser diode rather, uh, is found on the remote from our television, and it really is invisible. It is invisible light. So next. So in conclusion, to summarize all the information above that we had discussed, we can say that the prototype circuit was the basis of the innovation project, which is the LED blinker, and can be modified in further purposes, exploring how this circuit works and how this project improve will make our life easier as the technology advances. So, I guess that's the end of our discussion. And for any question, please drop your comment below and I hope I can answer all of it. So, that's all. Thank you for listening. I hope you enjoy and I hope you learn from me. And see you. Thank you.